Okay, welcome back to the Unity Lab session for the PBA class, this time for the 6th week. Yeah. Today we will try to simulate force. Okay, so what to learn today? We will learn about how to simulate force using the rigid body. So you are expected to have known about how to use rigid body. Yeah, if you missed last week's lab, please go back and learn it first. I will link to the playlist for the last week in the description below. Yeah, because you are expected to know how to use rigid body. Yeah, and also from now on, the TMP text, input fields, and buttons will be referred to as text, input fields, and button respectively. Yeah, if I tell you to add input field or a text or a button, please remember to use the TMP version. Okay. Okay, so for the preparations, please open your week 5 Unity project. Yeah, I have opened up mine here. And let me show you what to expect first. Yeah, this is the final result of the today's lab session. Yeah, this is the final result for the force. So I have two inputs here for the force. Yeah, let me enter some initial force, for example, like 100 newtons. Yeah, and then I will input the car mass also. Let's pretend the car mass is only 1 kilogram for now. Yeah, and then if I click the start button, yeah, the car should be moving using this acceleration of 100 meter per second squared. Yeah, if you calculate using the formula F equals to m times a, yeah, force equals to the mass times acceleration, yeah, you will get that the acceleration is actually force divided by mass. So here the simulation is correct. Yeah, 100 divided by 1 is also 100. Let me try it again. For example, I give the car 100 Newton of force, but the mass is, let's say, 1 ton or 1,000 kilograms. Yeah. So the car will move with the acceleration of 0.1 meter per second squared. Yeah, this is what you will get from today's lab session. Yeah, and the second part later, you will simulate the friction part, but I will give you the example for what to expect for the friction part later at the second part, okay? Okay, so for the preparations, if you have opened your week 5 Unity project, let's duplicate our GLB scene. Yeah, press Ctrl D and then rename it to force and please open it. Yeah, open, then okay, here we are told to remove the car script component from your car. Yeah, we'll change it with another script which is not created yet by now. Let's do that. From the car scheme object, let's remove this car RB script. Yeah, by clicking the kebab menu, yeah, or the vertical ellipsis menu here, and then choose remove component. Okay, that's how to remove a component from any game object. Okay. Okay, and the next part is to prepare the UI changes. Yeah, some UI changes. Let's prepare two input fields for inputting force and car mass, and then also prepare two text for displaying current velocity and acceleration. Let's do that. I will open my canvas. Let's focus on the user interface first. Yeah, and let's reuse this velocity text and input. Yeah, I will just simply change the text from velocity to force in Newton, and then I will also rename this to not speed input but force input. Yeah, and then let's duplicate this too. Yeah, Control D, and I will use my move tool to move them over here. I will activate my rect tool again. Then I will simply change the text of this to car mass. The unit is kilogram. And this one is no longer a force input, but it is, let's say, car mass input. Let's rename that car mass input. Yeah, and then we must prepare two text, velocity and acceleration here. I will simply duplicate this one. Yeah, text tmp1, duplicate. Again, I will move it over here. Let's say this position is okay for me. And I will change the text to velocity. Or you can also use a current velocity. Yeah, current velocity or velocity is fine in meter per second. And then I will duplicate this text tmp2, move it downward. And I will rearrange my text tmp3. Maybe over here is fine. I will give it the text of 0 first. And I will change the name to, let's follow the slide. Yeah, current velocity. Okay, current velocity. And for the panel part, let's duplicate these two texts. Control T again. Activate the move tool. Sorry, not move. Yeah, move tool. Yeah, this one. Yeah, move tool. Move it over here. Make sure that there is enough space. Yeah, and I will activate my rect tool to see if okay, those two texts overlap each other. So let me move it again. Yeah, you can always use the rect tool to move your UI elements. Yeah, but in this case, I use the move tool because I want to move these two texts in a straight line. Yeah, if I use the rect tool to move, I may drag the two text fields into somewhere else I don't want. Yeah, that's why I'm using the move tool instead. Okay, I think they are too far apart. Let me move it a little bit to the left, like this. Okay, let's see. Okay, I think that's fine, yeah. I'll change this to acceleration. You may want to give the unit also meter per second squared. Yeah, but we will need to resize this text. Okay, and then I will rename this final current velocity one text into, let's say, simply acceleration. Yeah, you can append text at the end of the current velocity name. Yeah, and as well as acceleration text. Yeah, to signify that both of them are text. Yeah, but it's optional. It's up to you. If you remember that both of them are text, then you can just ignore the text in their names. Okay, I think the UI is similar to the example in the slide. Let's continue then. Okay, let's create a new script, then name it car force. Okay, I already have car force here. I think I will rename it to something else. Yeah, for this one. Okay, I will just simply remove them for now. Yeah, I will delete them. Okay, let's create a new script. Name it car force. And then attach it immediately to your car game object. Okay, over here, I will check that my car already has the car force script. Then I will open it in my Visual Studio. Okay, let's see what's in our car force script. Let's add these public fields to connect the script to the UI. Yeah, we have two public TMP input fields here, force input and karma's input, as well as two public TMP tags, yeah, velocity tags and acceleration tags. Okay, let's add them. Public TMP input field. Yeah, you may want to import the tmpro namespace first by typing using tmpro at the top of your script. Yeah, but if your Visual Studio is smart enough to find the correct namespace, you can always try to type tmp input field. Yeah, and Visual Studio will try to import it for you. Okay, if not, then just remember to type using tmpro first. Okay, let's continue. The names are force input and car mass. Oh, one area car mass input, as well as public TMP text, velocity text, and acceleration text. Okay, and then let's add these private fields. Yeah, private RP, rigid body 2D, and then private vector 2 force, last velocity, and acceleration. The last velocity field will be used to calculate the acceleration. Yeah, if you remember the formula, we can calculate the acceleration by simply calculate the difference of the velocity from current frame to the last frame, and then we divide it by the changes over time, in time. Yeah, why factor 2 and not float, more on that later. Yeah, for now just type all of these fields are in factor 2. Okay, let's edit rigid body 2D RP and then factor 2 force last velocity and acceleration. Okay, that's all for the fields. The next one, at the start method, let's initialize everything here, as well as getting the rigid body 2D component from the game object. Yeah, RP equals to get component, and the type is rigid body 2D. For the initialization, let's initialize force equals to acceleration. Yeah, if you wish, you may also change this with the last velocity, but I won't do that here. I will just let the force and the acceleration equals to factor 2 dot 0. Yeah, factor 2.0 is a shorthand for the 0 and 0 factor. Okay, let me see. Okay, I think, oh, why my script is importing the system numerics? Yeah, I don't want that. Okay, yeah, make sure you don't have anything else than TM Pro and Unity Engine. For these two, using system collections and system collections generic, you can ignore them. Yeah, you can safely delete these two. Okay, that's settled. Then add a new method, pushCar, public void pushCar. Yeah, this method will be executed when the user clicks the start button. Yeah, so this is actually the listener or the event for the button click. Okay, we will get the force, yeah, by creating a new factor 2 with the x component is actually the value from our force input field. So here I will try to parse float.parse the force input dot text, and for the y component I will leave it to 0. Yeah, and then for the car mass, we will simply assign it to the rigid body's mass. Yeah, remember from the last week, yeah, rigid body has the property of mass. So here rp dot mass equals to float dot parse from the car mass input dot text. Okay, our button click is complete. Now for the fixed update message, yeah, remember what is the fixed update message? Yeah, if you can't remember, then please relearn from the previous labs. Okay, let's add fixed update here. Simply press Ctrl, Shift, and M, and look for fixed update. Yeah, click OK, and we can simply type everything here. Yeah, rp.addForce with the argument is force. rp.addForce. Let's keep it the force over here. Yeah, that's why the force is initialized using a factor 2, not a float, because it is used in the addForce method. Yeah, what is a force method? We will talk about it right away, yeah, after this. Okay, acceleration equals to the current velocity, rp.velocity, subtracted by last velocity divided by time dot delta time. Yeah, remember A is equal to delta. I will write it using a D, yeah, because here I cannot type delta. Yeah, dv delta v divided by delta t. Yeah, we know the delta t is stored in time dot delta time. For the delta v, we must calculate the current velocity subtracted by last frame's velocity. Yeah, that's why here we need to use another variable called last velocity. Yeah, and last velocity is initialized at the very end of the fixed update method. Yeah, we haven't done it so later. Yeah, don't worry. And then just display everything here. Velocity text equals to let's see, rp.velocity. Let's format it in two floating point precision. Yeah, and then for the acceleration text, we will simply give it the acceleration here also to string f2. Yeah, this means that the acceleration will be formatted in a floating point string with 2 decimal of precision. Okay, and then lastly, we will initialize the last velocity equals to current velocity. Last velocity equals to rp dot velocity. Okay, let's break down these lines one by one. Yeah, or at the important lines. Yeah, let's talk about rigid body 2D and the add force method. Yeah, the add force method from the rigid body 2D is used to apply a force to a rigid body over time. Yeah, it requires at least one parameter or one argument. Yeah, the first one is the factor 2 force itself, the amount of force applied to this rigid body. Yeah, this is why we need to store the force as a factor 2, not a float. And then the second argument or the second parameter is actually optional. It is the force mode 2D mode. Yeah, it sets whether the force is applied over time. The value of mode is force mode 2D dot force in this case. Yeah, which is also the default value. Yeah, that's why we can safely ignore it. Yeah, or the force is applied instantly if we supply force mode 2D dot impulse for the second argument. Yeah, the second one, the impulse can be used for a force that is applied instantly. Yeah, for example, like in an explosion or collision. Yeah, for this case, we must apply a pushing force constantly to our car. So that's why we will use the first mode, which is force mode 2D dot force. Yeah, and because it is the default value, we can simply call our add force method like this. Yeah, we can just ignore the second parameter. And the force will be applied starting from the next fixed update call. Yeah, so if Unity finds the add force method, yeah, it will actually apply it at the next frame. Yeah, that's why here we can store our last velocity or last frame's velocity to the value of current velocity at the very end of the fixed update. Yeah, at the next fixed update call, yeah, Unity will actually calculate the velocity because applied to the force, and then we can calculate the acceleration over here. Here, let's continue. Okay, recall that the acceleration is the difference of velocity over time. Yeah, thus we need the last velocity field over here. Yeah, to store the velocity of this frame. At the next frame, we calculate the acceleration and display it before updating the last velocity stored in the last velocity field. Okay, that's all for the script. Let's save this car4 script. Yeah, and then go back to Unity and set everything up before you actually test it. Yeah, remember here we have 4 public fields that need to be initialized first. Yeah, so let's do that. For the force input, we'll give it the force input field. For the car mass input, I will give the car mass input here. Yeah, velocity text, I will specify the current velocity text over here. And finally, for the acceleration text, I will drop it over here. Yeah, and then for the button, let's assign the listener, yeah, the on-click listener. I hope do you remember how to do that, yeah? Push car, and finally we can test it. Okay, I will use the exact same value from the slide. Let's have a force of 100. And then the car mass is actually, sorry, car mass is 10 kilogram, yeah, a very light car indeed. And let's click start button, yeah, and see that the acceleration is 10 meter per second squared. Yeah, if we calculate it manually, remember F equals to mass times acceleration. So acceleration equals to force divided by mass. Yeah, 100 divided by 10 is 10. Yeah, so we can assure that our simulation is correct. Okay, that's how to simulate the force in Unity. Quite simple, right? After we know how to use rigid body. Yeah, you can imagine yourself if you haven't known the rigid body at this point. Yeah, so you must calculate the force by yourself and then simulate the acceleration, calculate the acceleration, then add the velocity over time, and so on. Yeah, but using a rigid body, we can actually use the add force method to apply a force to a rigid body. Yeah, so it is quite simple. Okay, the second part is the friction. Yeah, I will show you the final result for the friction here. Let's see, where is my friction final? This one. Okay, if I specify, oh, sorry, the yeah, the script is missing. I have already deleted my script. I should have made a backup for my car script, which is now missing. Yeah, I don't think I can illustrate to you, but let me see. I will check if I have my car in the recycle bin. Oh, okay, I have it here. Let me restore it. Yeah, let me restart the script for once. And let's hope Unity will recognize it. Yeah, now that my car friction script is here. Yes, yeah, I will re-initialize my fields first. Yeah, please wait a second. Static coefficient input, kinetic coefficient input, velocity text, and acceleration text. And then I will check my button. It's still using the same listener. Okay, I think everything is fine by now. Okay, let's see. Yeah, if I have my car has a 1 kilogram mass, and then I have a 10 Newton force, yeah, push force, and I have the static coefficient of 0.5. Yeah, I use comma here because my setting is in Indonesian, and also my kinetic coefficient is 0.5. Yeah, let's check if my car actually moves. Okay, calculate the normal force, which is 1 times 10. Yeah, I will use 10 here. 10 meter per second squared for the gravity. Yeah, so my normal force is 10. My static friction force is 10 multiplied by 0.5 is 5. Yeah, my pushing force is 10. The static force is 5, so it's moving. Yeah, moving with the acceleration of how much? Yeah, let's calculate the kinetic force first. Yeah, the normal is 5 multiplied by 0.5. I have 5 in as my kinetic friction force. Yeah, so my total force applied to the car is 10 subtracted by 5. I have 5 Newton. Yeah, which means my car will accelerate. Let's see. I think it's 5. Yeah, it's correct. Yeah. Yeah, I have the acceleration in 5. If you cannot calculate these equations, or yeah, if you cannot determine if your car actually moves or not, you can do the calculation first on a piece of paper beforehand. Yeah, and then check it with the result of your simulation later. Yeah, this is to illustrate that this is what to be expected at the end of the second part of this lab. Okay. Okay. The illustration is shown already, so I can simply delete again my car friction script. I will also create the script from scratch with you. Yeah, let's do this. Duplicate our force scene. Okay, I will go to my scene, and then for the force scene, let's duplicate it. Control D again, and rename it to friction. Then remember to open it. Yeah, if not, then you are editing the currently opened scene. Okay, for the UI changes, yeah, we will need to add 2 more input fields for the static and kinetic friction coefficients. Yeah, because we have more input fields here. Let's rearrange our UI as necessary. Okay, I will expand my canvas first. And let's see. Yeah, I must move. Oops, sorry. Yeah, it is better to use the move tool here. And I will drag my car input over here. Yeah, for now, let's assume that they are aligned correctly. Yeah, if you are not sure, then you can simply realign them one by one. Yeah, I think everything is in place. Then let's see, I will group this 2. Yeah, 1, 2, 3, 4. Duplicate all of them and move it to the right side. Yeah, from here we can just change the correct text and names. Yeah, but let's see. I have my text mp4 is actually over here, and for the force input one, it's here. Yeah, so it doesn't match really. The text mp should be with the force input one. Yeah, and the text mp4 should be with the car mass input one for now. Yeah, only then I can start to make changes as it's necessary. Yeah, I will change this text to static coefficient. Yeah, or coef for short. If you want, you can also always type them in the full. Yeah, coefficient. And then this one is static coefficient input. For this text, let's change it to kinetic coefficient. Yeah, and this input field is no longer car mass input one, but it is a kinetic coefficient input. Yeah, for the velocity and acceleration, they are still the same. So our UI changes is complete. Okay, and then let's just duplicate our cars for script. Rename it the copy as car friction. Yeah. Well, why we duplicate the script? Because the concept is quite similar actually, but this time we will need to consider the friction as well. Okay, let's do that. Yeah, select your car force script, then duplicate it. Rename it to car friction. And because our file name does not match with the class name, we cannot attach it to our car game object yet. Yeah, let's add it first. Because the name is incorrect, rename it also to car friction. Yeah, only then you can attach this car friction script to the car game object. Yeah, I will do that first before continuing updating my car friction script. So at the car game object, remove the car force component and then attach the car friction script. Yeah, for now, don't initialize anything yet because we will need to make some changes here. Yeah, so go back to the Visual Studio and let's start to modify the script, okay? Okay, for the fields, we will need to add 2 more public fields as well as 2 more private fields. Yeah, adjust your field to accommodate both static and kinetic coefficients. So we have a static coefficient input and kinetic coefficient input fields here, as well as a private float, static coefficient and kinetic coefficient. Okay, let's do that. Let's add the static coefficient input and kinetic coefficient input, as well as 2 private floats, private float static coefficient and kinetic coefficient. Okay, that's all about the fields. The next one, let's adjust the button click method. In this case, is the pushcar method. To take both coefficients into account. So here let's add two lines. Static coefficient equals to float dot parse the static coefficient input dot text, as well as kinetic coefficient equals to float dot parse kinetic coefficient input dot text. Okay. Oh yeah. Before I forget, if you find your script has an empty update, just delete it. This is a recommendation from Unity themselves. If you have the empty update method, please just remove it. Okay, let's continue editing our pushcar method. Static coefficient equals to float dot parse static coefficient input dot text, and then for the kinetic coefficient also equals to float dot parse kinetic coefficient input dot text. If you have a hard time to actually remember the name, just type it in full, kinetic coefficient input. My Visual Studio is smart enough to guess that I want to actually type the kinetic coefficient input. So I can just type in the three letters, the three first letters from the name, K, C, and I. But if your Visual Studio cannot guess the correct one, then just type kinetic coefficient input. Actually I cheat a little bit here because I installed an extension from a JetBrains. If you are interested, you can ask me later. Either in the group chat or you can just comment in the comment section below. On how to install the extension. This is from the JetBrains, who also make the Android Studio if you ever use it. Okay, let's go back to our car friction script. For the fixed update, now here's the tricky part. We must calculate the correct force to be applied to our car, taking the frictions into account. Before we do that, let's simplify our calculation. Because the gravity in Unity defaults to negative 9.81. To simplify everything, let's change it to negative 10. Go back to Unity and then select the Edit menu. Then select the project settings. Find Physics 2D and change your gravity. The Y value is negative 10. I have done it previously. If yours still show negative 9.81 here, just change it into negative 10. Then simply close the project settings. Now Unity will use the 0 and negative 10 for its gravity. Okay, let's calculate the friction forces. This is done in the fixed update method. First let's calculate the normal force here. Factor 2 normal force equal to rp dot mass times physics 2d dot gravity. And then let's calculate the static friction. The Fs equals to the static coefficient times a new factor. We will take only the normal force, the y component, into account. Because if you remember, normal is pointing upwards. Actually, because we did the horizontal part, then we will just take the y component of our normal force, create a new factor 2, and then multiply it by a static coefficient to create a static friction force. And then let's prepare a variable, a helper variable here, total force. It will calculate the total force applied, but for now, let's default it to 0. Yeah, maybe you wonder here, where is the kinetic friction force actually? Yeah, because in these 3 lines, we don't find the Fk. Yeah, where is it? Yeah, remember, we must first check whether the object moves or not. Yeah, if it is, then calculate the kinetic friction force. Yeah, so let's check it first. If force added by Fs, let's only take the x component. Yeah, because the y component is always 0 in our case. Yeah, if the calculation or if the addition is greater than 0, yeah, it means that our object moves. So we calculate the Fk, the kinetic friction force here, yeah, in the similar way as we calculate Fs. Fk equals to the kinetic coefficient times a new factor with the x component being normal force dot y, and the y component is 0. Yeah, and then we simply sum our forces. Yeah, total force equal to force plus Fk. Okay, let's type these lines first, yeah, before we continue further. On the fixed update, at the very beginning of our fixed update, let's type this. Yeah, calculate normal force first. Calculate normal force. Prepare a factor 2. Normal force equals to the mass. Yeah, n equals to W or negative W, yeah. But here we simply use n equals to W, which W is mass times gravity. Yeah, so multiply the Rp dot mass by physics 2D dot gravity. Yeah, this will actually result in a downward factor, yeah, downward force. So if you want, you can always append a negative over here, yeah, to make your normal force points upwards. Yeah, but we won't do that here. Yeah, let's just continue calculating. Calculate calculate the static friction force factor 2 Fs equals to the static coefficient multiplied by a new factor 2 normal force dot y and 0. Then calculate the total force applied. Total force applied defaults to 0. Factor 2 total force equals to factor 2 dot 0. Yeah, and then we do check whether the object moves. Yeah, to do this, we simply add our force plus Fs. Okay, but let's take only the x component is greater than 0. Yeah, this means that the object moves. The object moves. Calculate the kinetic friction force. Factor 2 Fk equals to the kinetic coefficient multiplied by new factor 2 normal force dot y as well, and 0 for the y component. Yeah, and then we sum the force and Fk. Total force equals to force plus Fk, and that's all. Yeah, actually that's not all. Yeah, because we will need to apply the total force to the rigid body. Yeah, so simply make changes in here. Yeah, it's only a small change. For the add force method, we don't supply force anymore, but we supply the total force. Yeah, and everything is still the same. Okay, so your completed fixed update should be something like this. Yeah, vector 2 dot normal force equals to rp dot mass times v62 dot gravity, and then you calculate fs equals to this. Initialize a total force to vector 2 dot 0. Check if the object moves or not. Yeah, sum two forces, yeah, force and fs, and then check for the x component. If it is greater than 0, then calculate fk. Yeah, sum the force and fk, then apply the total force, and everything else is still the same. Okay, that's all for the car friction script. Let's set up everything now. Yeah, make sure you have saved your car friction script, then go back to Unity and initialize all these 6 fields, yeah, to their respective values. Yeah, so you can see here, if you name everything, if you name the UI component the same as the fields, then you can just simply drag and drop them to the correct fields. Velocity text is this one, current velocity text, and acceleration is over here. All set. For the button, let's specify the push car method from the car friction this time. Yeah, and you are ready to test your simulation. Okay, let's see. If I give a force of 10 Newton to a 1 kilogram car with the static coefficient is 0.5 and the kinetic coefficient is also 0.5, then our car will move with the acceleration of 5 meter per second square. Yeah, please try this with different input values. Let's try these values specified on the slide there. Okay, I have a force of 10 Newton. 10, car input is also 1, but the static coefficient is now 0.7, and then the kinetic coefficient is 0.3. So if everything is correct, my acceleration should be 3. Oh, sorry, 7. Yeah, because 10 subtracted by 3 from the kinetic force, yeah, is actually 7. Okay, what if the object does not move? Yeah, let's say I have a force of also 10 and the car mass is 1, but my static coefficient is now 1. For the kinetic coefficient, I will give it something smaller. Yeah, because in the real life, the kinetic coefficient is usually less than static coefficient. Yeah, let's calculate it first. Let's determine if the object actually moves or not. Yeah. Okay, I have the car mass is 1, so my normal is 10. Yeah, mass times gravity, 1 times 10 is 10. So my static force is 1 times the normal, 10, is also 10. If I sum my static force, static friction with my push force, 10 and 10, it's actually cancels out. Yeah, because remember the static force, static friction force works in the opposite way as our push force. If our push force goes to the right, then the static force, static friction force should go to the left. Yeah. So my push force is 10. The static friction force is -10. Everything cancels out. If I submit, then my object or my car here should not move. Yeah, see? The acceleration is 0 and the velocity is actually 0 as well. So you know that the simulation is correct. Yeah, but if somehow I change my static coefficient to 0.9 here, yeah, I will get the sum of the force is 1 Newton. Yeah, that means my object or my car here will move. Yeah, but with how much acceleration? Yeah, you can calculate it. Let's try to do this without using any paper. Yeah, I have the force 10. The kinetic force should be 0.5 times 10. Yeah, remember the normal force is 10. 0.5 times 5. Sorry, 0.5 times 10 is 5. Yeah, 10. Let's not use 0.5. This is the last value. Let's use 0.6. Yeah, so my kinetic friction force is now 6 Newton to the left. My push force is 10 Newton to the right. The sum of the forces is 10 subtracted by 6 is 4. So my acceleration is 4. Okay, nice. Yeah, you can use another value. Yeah, let's try to actually use some exercises here. Yeah, let's see. Okay, let's try this. Yeah, a box with a mass of 5 kilogram. Let's input 5 into our car mass, and then it's pulled with a force 25 Newton. 25 with a static coefficient is 0.4, 0.4, and then the kinetic coefficient is 0.2. Yeah, according to our discussions before, yeah, previously we have discussed this one. The acceleration should be 3 meter per square, 3 meter per second squared. Okay, this is the moment of truth. Yeah, will my car moves with the acceleration of 3? Let's click start. Yes, yeah. My car moves with the acceleration of 3 meter per second squared. So the simulation is correct. Yeah, conforming to the Newton's law. Okay, that's a relief, yeah, actually, because to be honest, I have not tested the exercise 1 to this simulation, yeah, but thankfully the calculated acceleration is actually correct. Okay, so let's continue. I think that's all. Let me check. Oh yeah, that's all. Yeah, we have reached the end of our lab sessions today. Yeah, I hope you enjoy simulating the force and friction force as well in Unity. Should you have any questions, please don't hesitate to ask to me, yeah, in the Hangouts group chat, or everyone else can always comment in the comment section below. Yeah, that's all for today. Thanks for joining with me. I will see you again next week.